Good day to you, students. I hope you guys are doing fine in your various homes. In our last class, we discussed calculations involving equilibrium constant, where we solved series of calculations involving this subtopic. Today, we are looking at another topic titled Ionic Equilibrium. Ionic Equilibrium. And before we proceed, there are certain things we need to know about this topic, that is the concept of ionic equilibrium. When you look at most of the chemical or biochemical reaction that takes place in existence, we will discover that most of them are always in aqueous solution. And such reaction is said to contain what is called ionic compound. Don't forget our knowledge on ionic compound. That is, ionic compound is a compound that is formed from electrovalent bond. And one of the properties of ionic compound is that they have the ability to dissolve in water. That is the reason why we wrote this here. Such reaction involves chemical compounds that are ionic in nature and have also dissolved in water. Anytime an ionic compound dissolves in water, there's going to be a separation of ion. And this is because water is having the ability to separate compounds into different ions, that is positive and negative. Let us look at sodium chloride as a typical example of this. Whenever sodium chloride dissolves in water, it forms, this is sodium chloride, to give sodium ion plus chloride ion. So this one is the positive ion, while this one is the negative ion. Okay? Anytime you have separation of a compound into different ions, you call such process ionization reaction. You might be asked to define what ionization reaction is. I think that is simply the definition of ionization reaction. Now, whenever you have separation of ions in a chemical reaction, a time may come when you now have equilibrium between these ions that are formed. Then at that point, you say the system is in a state of ionic equilibrium. Ionic equilibrium. Okay, now let's proceed. There are two types of ionic equilibrium. We have the one that has to do with acid and base, which is called the acid-base equilibrium. And the second one is the solubility equilibrium. But today, our highlight of interest will be concentrated on the acid-base equilibrium. Before we can have a deep understanding of this, it is very important for us to have a very good reference to our definition of what an acid and base is. There are three schools of thought as regards the definition of an acid. The first one is the Arrhenius definition. Arrhenius defined an acid as any substance that produces hydrogen ion or hydrozonium ion as its only positive ion whenever it dissolves in water. While it also defines a base as any substance that produces hydroxide ion as its only negative ion when it dissolves in water. Let us look at the second definition proposed by Mr. Lewis. Lewis defined an acid as a substance that accepts electron. That is why you call it electron pair acceptor. That is an acid, while a base is defined as an electron pair donor. Then lastly, we have the Brustolori definition of an acid and a base. Mr. Brustolori defined an acid as a proton donor, while he also defined a base as a proton acceptor. Now, let us now concentrate more on the Brustolori definition of an acid. We said Brustolori defined an acid as a proton donor and a base as a proton acceptor. It is very important for us to know the meaning of a proton. Proton is always referred to as hydrogen ion concentration. And why did we call it hydrogen ion? This is because anytime you have, let's assume this is hydrogen, and this hydrogen is only having a single electron. That's the number of electrons. Inside this, you have nucleus. The nucleus contains proton and the neutron. And this proton is having 1, while neutron is 0. So let us now assume that we remove this 1 electron from 1 hydrogen atom. That means you are only left with the nucleus. This atom's electron will be moved off. Then in this nucleus, all we have there is 1 proton. And anytime hydrogen loses electrons, it becomes H+. That is why we say proton is referred to as what? It's represented with H+. You might be asked, that is one of the IGCSE questions. Explain why proton is referred to as H+. Okay? According to Brewster-Lowry concept, let us consider this reaction here. Let us consider the ionization reaction of hydrogen chloride gas. This hydrogen chloride gas is an acidic gas, so it is representing an acid. And this is water. Because of the amphoteric nature of water, that is, it has the ability to react as an acid as well as a base. So let us assume that this water is reacting as a base. Then that is HCl plus H2O. It will now give H3O plus Cl minus. How did we arrive at this? Don't forget that we have said it earlier on that acid is a proton donor. So the proton you have here, that is, this is the proton here, will now be donated to this base, that is the water. So when this proton moves to meet the base, it becomes H3O plus. So that is what it produces. Then, the moment you remove this H plus from this HCl, what are you left with? You are left with what? Cl minus. Now, any acid that is, this one will now become the second acid of that reaction. And this second acid is called the conjugate acid. Conjugate acid is any acid that is obtained from a base. When you look at this acid is obtained from H2O. That is, H2O becomes H3O. So the conjugate acid of this base is H3O plus. Then let's look at this conjugate base. Conjugate base is any base that is obtained from an acid. This HCl is obtained from where? From this Cl minus is obtained from HCl. So this is the conjugate base of HCl. Now, you might be asked, what are conjugate bases? Conjugate bases are those acids, conjugate acid. They are those acids that are obtained from a conjugate from a base, while conjugate base are those bases that are obtained from an acid. Alright? I believe with this short description in my video, students should be able to identify what a conjugate acid and a conjugate base is whenever you have ionization reaction of an acid. And we must also be able to explain the various schools of thought as regards the definition of an acid. Among the many more explanations we still have in the Google Classroom, I expect us all to watch this, and I will be expecting you all in the Google Classroom. As you watch this, I pray that God bless you. Thank you.